YouTube everyone, welcome back to another video. And no, this is not a daily teardown, it's just gonna be me showing off something that I found, and it's very interesting. So this right here is an LED bulb, but not your typical kind of LED bulb. It's a very strange LED bulb made by kanlux. It's the G4 variant, similar to this one, but this is a more normal sized one. It's about the same dimensions as a halogen bulb. So here's a halogen bulb. A bit taller, but still pretty bright. I can't run the halogen because it's broken, but I can definitely run this LED. It's not a non-polarized variant, so you have to put it in the right way for it to properly work. But it's pretty bright. It's designed for DC, not AC. But I have a transformer, so we can provide it AC as well and see how it acts. And also we will see if this one acts any different on AC and DC. But this one is a bit more professional than the other one, which is homemade. This one's bought from the store. kanlux 1.2 watts, 140 lumens. Yeah, it says AC, so it must take DC. My transformer supplies 50 hertz. Well, it takes 60 hertz as well, so there shouldn't be a problem. And I'll tell you why it does so. If I see what that mean, I don't know what does that mean. Small size, well, it's a flat round disc designed for spotlights that have the connector not coming from above, from the side. So you're supposed to place it down like this to direct the light. It's directional. It's a spotlight. 120 degrees G4. This is the daylight variant. LED 12 is probably just its name. Is anything else on the back? Yeah, there is a lot. It takes 12 volts DC, so no luck powering it from AC mains, but we can share power from low voltage AC. Let's get it out of this box. It's a collectible, you have to be careful with it. No, the plastic is just flying. Yeah, we'll have to collect it. You know, it's a collectible, we have to collect the plastic. No, we don't. Let's get it out of the box real quick. This is the plastic part. Not useful again. The bulb itself. Before we take a look at the back of it, let's take all this nonsense away. Let's just test this bulb real quick with a new socket. And it does work. This is a DC supply. It draws about 0.10 amps. So let's do some math here. At about, let's see, 12.0 times 0.10. No, 0. Well, I've reset the entire thing. Let me do it off camera. Yeah, it is 1.2 watts, so it's not actually a lie. They're not lying when they mean 1.2 watts. Let's put the calculator aside. Let's grab the bulb again. It is actually running, and this is the back of the bulb. So it works surprisingly nicely, and it's surprisingly bright as well. It's daylight. It definitely is daylight, so they're not lying. Well, it's a reputable brand. kanlux makes great LED bulbs. But this thing is pretty good in terms of what it supports, and it supports DC as well because it's got a rectifier in it. That's why, of course, it supports both AC. Let's put it in the opposite way. And it's kind of blinking, but let's make sure we get it to put in there and work. One orientation, other orientation, it works. Like this LED bulb right here, which is homemade. It turned on. It works. Oops. It's double-sided, but this one's designed for other applications. Let's put it in the wrong way. Wrong way. Right way. This one's polarized, so it's not AC, it's designed for DC. Let's do a brightness comparison. I don't have a halogen to compare it with, but let's just see if this homemade one is bright or brighter. Well, this one is not directional, however, this one is directional. So here's this proper one. And here's the homemade one, which is not directional. So you may be able to tell that this one is slightly more different than the other one. This one has a shadow when you place it like this. When you place it like this, it's just about as bright, a little less, but this one is designed for all around illumination, but you get that annoying shadow in the middle because of the LEDs. But it's worse with the other one. It's definitely way worse. This one, barely illumination, an annoying shadow, so this one's clearly directional. But there is the back of the board. Now let's take it out of here. I'm gonna zoom back out. There's the plastic is still left here. So, surprisingly, comparing the temperatures of both of the bulbs, the smaller one seems to run much hotter. Well, let me just turn them on both and see how hot they get. The first one, let's just let it run. Okay, check the first bulb. 42.1 degrees, that's a lot. It's quite hot. Well, this one's a bit of a more powerful variant. A 2-watt bulb compared to a 1-watt bulb. Let's put in this one and test it as well. Okay, now let's check this bulb. 40.4 as well. Well, comparing them is quite simple. The other one, which is the smaller one, is approximately 2 watts. And this one is 1.2 watts. So this one is a bit more powerful at about 1.2 watts. Well, this one also has a couple of extra components added to it, which we can see on the back. It's of course the most big capacitor here. And this is the main smoothing capacitor. Is it glued on there? Is that some tape? Oh, I'm seeing what it is. Why did it put the capacitor right over the label on the bulb? That's interesting. So you have like a bended back when you have to check the values? Because whoever thought this through clearly was not thinking about making it easy to use. They clearly didn't know what they were doing. Well, I have absolutely no clue if that is exactly what they have done here. And if that is exactly what they have done here, it'll be a shame. Also, the mouse clicking in the background is pretty annoying. But one more thing that we can see with this particular bulb is that there are 4 discrete diodes instead of a normal rectifier package, which is more common with bulbs like this. D1 is a rectifier, even though I'm not sure why they called it D1. There's more diodes inside. There's approximately 4. And for this bulb, I was expecting just to be the same kind of rectifier here, but no. Why did they put in the LED bulb? That's 220 volts. I have absolutely no idea. I guess they put it with the 4 diodes in this one. And there was also the small IC, which is very similar to another bulb that I took a look at but didn't film it. An inductor and a resistor for the LEDs, of course. And a diode. Well, much more simple, but still, it is a constant current driver. So yeah, it does have that. No resistor. Unlike the smaller bulb, which is tolerant to low voltages, which I can definitely do with my power supply. Okay, put it in the other way. There, it's on. Let me just drop the voltage from 12. And as you can see, it's dimming. 10.39 volts. Now bring it back up to full 12. We can see it's slightly brighter. But however, the other bulb, the homemade one, I'm not going to be overvolting it. What about putting voltage into this one more than it's rated for? Let's see. It's out of focus. And there's also like a weird thing that's coming up. A blue pattern, probably because there's blue LEDs in here. Let's just drop the voltage. In terms of brightness, it's still bright. And now it's dimming. Well, it is dimmable. I think it's dimmable. Is it dimmable? I don't know. I have no idea. Definitely brighter. Let's see if it draws more power. 13. Now it's drawing less watts. But certainly pretty good. So it supports lower voltages, but up to a certain degree. Maybe the packaging tells us if it's dimmable or not. But I've already cut and destroyed the entire package. Let's see. Fortunately, I didn't cut part of the box that was needed. It's not dimmable. Not like it was necessary, but because I dimmed it with about 10 volts or so. Probably doesn't work with the normal style of dimming, but the voltage dropping is sure possible. I don't have power factor or all kinds of measurements, but it definitely works. And compared to the other one, it dims much more. This one is dimmable. But how does it act on AC? Well, let's find that out as well. And now, we are powering off of AC. Now it's 26 volts instead of 24 volts. But it's going to drop under a load. So, epilepsy warning because it's going to be very insane. This bulb doesn't like AC at all. And just look at the flicker on that. That's worse than a fluorescent bulb, 50 Hz AC. Keep in mind this light is flashing off and on 50 times a second. It's not as flickery on camera. I could sure try to film. The hand is not acting as it would on AC, but the bulb is clearly not liking it. Especially just looking at the amount of flicker. The voltage is about 20 volts on the bulb. Let's get it out of here. Ugh, it's hot. What's the temperature on AC? Let me find that out. Let's leave it plugged in. Before this thing manages to shock me, it is isolated, so let's turn on the thermometer. Surface. Check its temperature. 46.6 degrees. Say it again. 52.8 degrees. 46.8 degrees. 54. Pretty hot for a bulb. And the glue is already starting to kind of melt on this one, so let's just leave it alone. It's not liking the AC. Let's put in this generic bulb. I'm really not worried about frying this poor one. And would you look at that? It turned on and it's working. This one is rated for AC, so it just turned on and it does work perfectly fine on 25 volts. So yeah, it does seem to support that AC voltage. Yeah, it works on AC fine. Just about as fine as it could have possibly ever worked. There is no noticeable drop on this one, which is about 1.2 watts. Let's take this one out here. Let's pop in this bulb. The 20 volts, and one of the sides is burnt out. Oh my gosh. The bulb is not happy anymore. Is it burned? Oh my shit. Looks like the bulb is trying to get itself alive. It's not acting very nicely. The voltage drop is non-existent. Well, let's get back to DC now. We are back to 12 volts DC instead of AC. Kanlux survived it. Let's see if the other one did. Oh, wow. The bulb is fine. Very odd behavior. Both the sides are working. Okay, I've never expected that behavior. So the kanlux is sure better with AC. Clearly this guy was turning off, and it is turning off a whole lot. But when I series them in AC, what will happen? Well, let's find out. Okay, we are back on AC. Also touched the voltmeter because I forgot about it. It's a bit of a pity that there's such a big disaster here, but let's fire above up. And they're working. We're about 24 volts AC. Things are acting a little more under normal operation. Let's do a comparison. The voltmeter on the floor. Let's make sure it's not on the floor. Well, let's just put something over the other bulb. Doesn't disturb any of the readings we're trying to get with the bulb. And yeah. I'm gonna go ahead and put the multimeter back up here. Sadly, the light does not work, so I cannot light it up, but we can light it up with the bulb. Let's turn on the bulb now. That's interesting. It's flashing a lot more in series than it is in parallel with the power supply. That's odd. There's a transformer over there. There's a flashy bulb. And the other one is, of course, flashing because it's AC and not DC, which is what the bulbs are rated for. So, let's see, why exactly is it acting like this? Well, I think it's because the other bulb is in series and it's doing something strange with the power supply. And I know what it is doing with the power supply. The other bulb, being DC, it's going to cut the power when it's 1/2 of the wave. So, that means this bulb loses its power when the other bulb cannot light up, because it's a diode after all. So there's no moving, but if I had a capacitor, I bet it would probably work. I'm not sure. I'm not a capacitors to this thing because I may want to blow them up by accident, but it clearly works. And that explains why our bulbs are flashing so much. And then let's have a look at this one. Just have a look at the flash on that one, and the flash on this one. They're flashing a lot. So both of them are flashing 50 hertz. But let's get back to DC to show that it does not act the way that it used to. And more importantly, why it actually acts the way that it does. Why this one flashes as well. Okay, now I'll turn on the DC. And this bulb is not glowing at all. Let's see what happens when I disconnect this one. The reason why it's not working now is because it's DC. Let's put this one in reverse. If anything acts differently, it does not. None of the bulbs light up except for this one, which has no constant current driver. So the bulbs are no longer receiving the right voltage. Well, this is how they act in series. It glows a bit, but not much. And now that we're back on DC, let's do a flicker test. No flicker. So it was clear that it was flickering on AC, and yeah. So without further ado, that is the rather basic LED something, LED 12 maybe, from kanlux. It's a generic not bidirectional, it's just an unidirectional bulb. This one is a bidirectional. It projects the light in both of directions. Daylight. Pretty good in terms of what it can put out. It can put out quite a lot of light. I think it's brighter enough in the laptop screen. No, it's not. I don't think it can overpower that. Definitely cannot. It doesn't run very hot. It has a constant current driver, which is based on a similar IC to the other bulbs that I've taken a look at. And yeah, it's relatively inexpensive, simple. Comparing the size, it's slightly larger to another LED disc. This one's slightly larger, but this one's small and pretty bright. They did a good job of compacting all the components into a small space. We have a nice smoothing capacitor. I bet it flickers a lot without smoothing capacitor. And 100 microfarad. 100 micros. Not a whole lot. Bet it would have been better, but no, it's okay for this bulb. So thanks for watching, everyone. I hope you liked this video, and I will see you in the next one.